outputs, control your inputs. That's it. That's what you are saying. Okay, so if you want to control the outputs, you need to control the inputs. And if the limit exists, for every bunch of values, okay, onto the curve, you can always find a bunch of inputs actually onto the xy plane, such that if you consider their outputs, the outputs are going to be wherever you want them to live at. Okay, so this is what is the key thing, and that's an important thing to realize. We'll talk more about it in real analysis. Whosoever is going to teach you the real analysis course. Okay, let's get rid of it and let's get into the calculus 3. Okay, so with this intuition, try to give me the definition for the limit here in higher dimension. So imagine I have roughly a surface in 3 dimensions, and this is like its domain. Okay, so if I take f and operate onto each of point of the d, then I collect all outputs and make a graph of it. The graph would look like this. Okay. So what do you think here? What would be the meaning of having this epsilon delta? So there are 2 ways actually that we kind of try to understand the definition of limit actually. One way is this left hand and right hand limit. So I would like to also invite you to think over what would be the meaning of having a left and right limit here actually. Are we going to have left, right, or more directions to move towards the point actually? That's one way to do it. And this other way that you have a limit and you want to stay close to the limit, so you need to choose inputs from the domain in such a way that from that chosen part of the domain, if you compute their outputs, the output would stay there in the part of the curve wherever you want to live them, wherever you want to put them at. So first of all, let's think about that. So let's take a point here, okay, and maybe this point is AB, okay, and this point is AB, okay, and I have a point, what do you say, on this. So what would be the coordinate of this? It's going to be A, B, and I want to get closer to this point AB. So let's think from this left hand, right hand limit perspective actually. So I want to reach to this point. So how many ways I can reach? So I have a lot of directions. So I can choose a point from XY. Okay, I can choose a point from XY, and I can try to reach from here to here. To here. So there are many directions in which, so there would be no left and right here. Yes. There would be no left and right here. And the meaning would be precisely the same, that if you have these bunch of points and you set up a curve actually on which, using that curve, you want to reach close to A to B. So I know that since this curve or this bunch of point is part of a domain, so I can operate f on it. So corresponding to this curve, I'm going to get a curve on the surface actually. Okay. So if this is AB and this is XY, which is arbitrary point, so I'm going to have an arbitrary point here, which is XY and f of x. Okay. So if these inputs, arbitrary inputs, x and y, are getting closer to AB through some way, which is here a straight line, and it's not necessary that it should be straight line. I can reach in this manner as well. So it could be a curve as well. Okay, so I can go here and there, and I can return here actually. I get the point. So that's what is another important thing. So as on this curve, I'm getting the the points x, y are getting closer to AB, okay, then the outputs of the function will get closer to, you know, this A, B, f of A and f of B. Is it making sense? And what is the relationship between this line and this line? Okay, so if this is a set of points, let's call it S, okay, so S is a set that contains all of the points of this line, then this is what? This is basically f of S. That's f of S. Okay, so on S, if xy is getting closer to AB, like this point is getting closer to AB. If you consider them dynamic actually. Are you getting the point? And as I said, it's not necessary that to reach this point, okay, to reach this point, you know, what? To reach this point, I'm choosing this curve, but it's not necessary to choose this curve. You can choose any curve. Okay? You can choose any curve. And that would be the meaning of saying that limit xy gets closer to, you know, AB is equal to f of xy equal to. That's what the meaning of it is. Is it making sense? In one dimension, when limit doesn't exist?
Right or left equal now.
When right and left are not equal. So in other words, you are taking two paths, but the two paths are giving you two different answers actually. So you can do the precisely same path. So there are many ways from which I can reach this point to this arbitrary point to this fixed point. So using this curve and some other curve, and if I can find two curves, okay, for example this curve and this curve, and when I'm approaching closer, I'm getting closer to the point AB through this curve, and I'm getting closer to the point AB through this curve, and if I'm getting the different outputs actually, you know, if this is not same, you will say limit doesn't exist. Like some value L actually. It's not necessary that it should be, because you're not talking about the quantity, you're talking about the limit actually. Okay, let's call it A, you know, which has some coordinates, maybe, you know, what do you call it? Okay. Unknown, alpha, beta, gamma, something like that. Okay. Is it making sense? I would just like to give you the picture actually. So that's a rough analog. So there you have two dimensions, two directions. You know, so if I have an arbitrary point x, I can reach to a fixed point A from the left and from the right. But now, you know, say if you are not in line but you are on plane, to reach from one point to another point, you have, you know, different ways actually. Okay. And in one dimension we know that if I approach from left or from right, if I'm getting the same value as an output, okay, as a limit, then you can say the limit exists in general. And similarly, no matter what curve you choose to reach from this set of arbitrary points x, y to a, b, okay, you should always reach to the same point L actually. Are you getting the point? Roughly, that would be the picture of it. That's left hand, right hand, analog here. So why I'm emphasizing on different, you know, just throwing all these details to you, that when I'll define it abstractly, you will know that why I'm defining it in this manner. Right? Otherwise, you know, learning a definition is like a God-given fact. You know, God said to someone, you know, that's a definition of the limit. You know that, you know, someone has thought about it. It's very practical. Okay? That's left hand, right hand side limit. But if you have still questions, you can ask. Okay? From this point to this point, you can reach through many different paths. and if this is a path, this path is going to have an output path here actually. So as you are getting closer, xy is getting closer to AB using this path, you know, this xy, f of xy, z, f of xy is going to get closer to this L, okay, using the output of this path actually. Okay. And no matter what path you choose to reach from here to here, and if you have a path here, we're going to have some path here maybe. So maybe the outputs of this path is this. Okay. You should always reach to the same value. So if you have found two paths for which you have different values, okay, for which you are getting two different, what do you call, limiting points, you're going to say limit doesn't exist in that. And when the limit would exist, no matter what path you choose, you will always hit this point actually under that aspect. Okay?
Sir, in two dimension it was simple that left and right limit. So we have just two choices. But here, sir, if we select any two curves, maybe from from this surface, one side there is a hole, and we are not selecting that curve which belongs to that hole. So then it might be that.
I mean, there is always a skepticism in here. Who knows actually that? So we will see that for example, when you are computing limit x goes to 0 sine x over x, okay, you know that it will be 1. So when you are computing, you don't think about left hand and right hand limit. You just try to directly compute it. If you know that if a direct limit of some function exists, the left and right limit would exist actually. It's not a fact, but that's what is going to happen. Okay. And similarly, if I have been given a function f of xy, and I take xy goes to AB, but you have to keep in mind, when I'm saying xy goes to AB, doesn't mean that x goes to A and y goes to B separately. No, that's a different thing. This as a point getting closer to AB, but through some curve. If you are able to compute it directly, for example, if I have the limit xy goes to 0, 0, and I have a curve, say x square plus y square, okay, then you would say that this is 0 square plus 0 square equal to 0, due to some strange reasons. Okay. So if such a limit exists, so when you are computing this, basically you are saying that no matter what path you choose to reach from this arbitrary point, make this set of arbitrary points closer to 0, the outputs of this function is always going to get closer to 0. Okay. So that's one way to look at it. Still, it's a rough sketch. I'll get into it very precisely. Now I would like to talk about the second part. Second way of thinking about the same function. So imagine I have the domain, and corresponding to the domain I have this surface actually. Okay. And I have a point, say A here, and I have a point whose coordinates to which I am representing by L, and it has some coordinates alpha, beta, and gamma. Okay, alpha, beta, and gamma. And by L I mean, so that's the value L actually. In other words, the third coordinate of this point is L actually, because it has height L. Okay. So what do you think? What should be that interval analog actually? That if you want to stay closer to a fixed number onto the curve, okay, you need to choose some point around, what do you call, a point in the input line in such a way that if you consider the inputs of that, input from that interval. Okay, roughly, I'm talking very abstractly. I know that. Okay, so you know that what I'm talking about. Actually, the question is, what would be an analog here? Actually, What should I do?
So, sir,
At this point,
sir, it will be a ball, I think.
not necessarily a ball. So you can take some region. I want to stay here. So that's a set that contains my point around it. I mean, if you wish, you can have a ball as well.
A piece of ball, sir.
Piece of ball or whatever. Okay. Imagine you have a ball as well. Okay. The question is, can you find what? A region around this point, small enough region around this point, in such a way that, you know, if you compute the outputs of all these points, okay, around this point, you're going to get, you know, outputs within this, you know, set that you want the outputs to live actually. Is it making sense? Instead of one dimension intervals, you have now these sets. Okay? And that would be the definition of saying that what is the meaning of having limit xy goes to ab, f of xy equal to l into b. यही टाइम मिला था ये खर्च मारने का। क्या हो रहा है?
Sir,
फैन चल रहा है।
ऊपर हवा की वजह से जैसे मौसम जब चेंज होती है, बरसात वगैरह से
इसके लास्ट में तब्दील करें। यार इतना तेज तो फैन नहीं।
सर जी अभी इतना तेज नहीं है सर, बरसात के दौरान इतना तेज होता है कि हम एक बैठे सर, खास कर लीडर की क्लास है सर, सब होते हैं।
वैसे ही नहीं समझ आता ये भी। दिल से हंसी निकलती है। Can you see how does it work? ठीक है, समझ आती है बात?
सर एक सवाल है सर, अगर हम इसको सपोज करें कि एक ऊपर पॉइंट है सर, जैसे अगर इसके नीचे एक पॉइंट जाएगी तो उसके लिए दो आउटपुट होगी, एक नीचे अगर बॉल कोई भी हम सर्फेस बनाए इसका टुकड़ा, तो एक तो नीचे से पॉइंट होगी, इसके ऑपोजिट में एक ऊपर भी होगी, तभी तो कवर करेगी।
ये हम अज्यूम करेंगे ना कि भाई ये कोई डबल क्रॉसिंग नहीं होगी।
ऊपर हम ऐसा खोल देंगे सर इसका, ऊपर जैसे इसको कनेक्ट बॉल बना देंगे।
कनेक्ट से मुराद ये है ना कि you have this surface with you. You have this surface with you. So I'm saying that a point here, you know, I have output here actually. There is no up and down to this surface actually. It's just one as a complete picture. समझ लेंगे. So whenever it's touching it, समझ लेंगे ये point यहाँ color हो गया पूरे surface पर.
Assume करेंगे सर हमारे पास।
So अगर आप इस point के यहाँ रहना चाहते हैं और वाकई लिमिट एग्जिस्ट करती है, तो फिर आप इनपुट के गिर्द छोटी सी ऐसी बॉल जरूर ढूंढ सकते हैं, एक सेट ढूंढ सकते हैं, सच दैट कि उस सेट में से उठाकर जब आप आउटपुट्स देखेंगे तो वो जहाँ आप रहना चाहते हैं, ठीक है, उसी रेंज में आपको आउटपुट्स देंगे। ठीक है, तो आप कहेंगे भाई why this represents nearness? I mean you can make it small as you want actually. So that's a big, ये तो मैं सिर्फ इस वजह से दिखा रहा हूँ कि नजर आएंगे। We're talking about, you know, one this big set actually. ठीक है, but you can make it small as much as you want. ठीक है, you know, I can get really closer to this point. इतना बहुत है? Really get closer to this point and corresponding to it, can I find a really close points to this point actually in such a way that if I consider the outputs of this set, it stays here actually within this range. ठीक है? समझ आ रही है बात?
Yes.
Good. Let's write the definition of a. So that's the definition of something. Yes. आ रहा है मुश्किल सवाल है। हाँ।
यहाँ पे जो रीजन होगा सेंट्रल को मैथमेटिकल एरिया का यहाँ पे अगर हमारे पास ये रीजन है करें उसको मैथमेटिकली कैसे नाल
That's what is the artistic thing now coming, you know, the real definition actually. Okay? But now when I'll write the definition, you will see that what I'm talking about actually. Otherwise it's very abstract.